Hello everyone, I am Nathan Saraiva, PhD candidate from University of Campinas, Brazil. Today I'm going to present our work CLARA, Closed Loop Based Zero Touch Network Management Framework. In this presentation, I'm going to start with an introduction and context regarding our research area. I'm going to continue with motivation, problem statement, and a little background related to works. I'm going to focus on approach and contributions, and finally present the publication and conclusion. Well, relevant technologies such as software network, network function virtualization, intent-based network, and network slicing bring many benefits for 5G and below networks. These benefits include flexibility, for example, make changes in runtime, programmability, define how to create and manage networking services, and support to advanced service offers. All these technologies are involved in a software-centric paradigm. However, this softwareization environment increases management complexity and the new services demand more advanced requirements. Then, automation capabilities become essential to provide efficiency in the managed process, reducing error-prone configuration, and raising service deployment agility. Because of that, the management system needs to provide a fully automated network environments, so-called zero-touch networks with minimal human intervention. For that, a zero-touch architecture should include features like the use of the intent to represent the business requirements, automate network management, translate of intent into policy, use of the machine intelligence to make decisions and generate insights, and support to multi-domain scenarios. In an end-to-end multi-domain scenario, each domain can have one or more CCL working collaboratively. For instance, this figure illustrates a scenario with four domains: cloud, transport, core, and run, and end-to-end closed control loop coordinate the interaction between different closed control loops to achieve a desired goal. In this work, we propose CLARA, Control Loop-Based Zero-Touch Network Management Framework. Our objectives include mostly reduce the network and service management complexity, enable network automation through CCL and artificial intelligence methods, and reinforce policy in a ZSM-based architecture to govern service behavior. In short, our objective is to manage service in network after they are provisioned. The next generation networks complexity management, novel application with extreme requirements, lack of automation and flexibility in the management of service and network lead us to raise the following problem and statement. Problem statement number 1. How to conceive appropriate closed control loop mechanism for different use cases fed by a network policy. First, we review a wide variety of solutions, identify gaps and limitations. So we develop a CCL platform driven on three real aspects: knowledge, create a knowledge base; modularity, it's simple to add or remove components; and portability, to be used in different domain and use case. Problem statement number 2. How to build a management model that abstracts the managed entity, decouple the service management from the service provision. To answer this question, we propose a methodology that automatically captures the user requirements, intents, and converts them in a service management model. That model should be case independent and agnostic, but must provide enough information to build management policies. Problem statement number 3. How to add flexibility to policy-based CCL automation solutions. To provide flexibility, we take advantage of technology as intent-based network to abstract the user requirements. We also adopt adaptive policy that manage closed control loops and autonomic actions driven by a probabilistic knowledge graph. We split the background and related works into 3 fields. Regarding the closed control loop automation, we highlight some works like map loop, monitor, analyze, plan, and execute, created by IBM, and map knowledge that add cognitive aspects inside the closed loop. Some solutions like ONAP and open source manual standard effort as at CCL. In the context of intent-based network, we can point to the Network Management Research Group from YETF and some works in the network slice field like Abbas and Gomes. Jacobs and Crave propose solutions related to policy-based management and the service deployment. Its contributions in the development of this work are mapped as illustrated in this figure. For example, closed control loop platform, adaptive policy-based management, service management model, and the framework CLARA. Now, I will provide a little more details about each approach. As we mentioned in our problem statement, we build a platform where the components are connected by a well-defined REST API. The knowledge components provide insights to build complex metrics and realize root cause analysis. The policy provides more flexibility in the definition of policy. Besides, the platform provides environment for testing and programmable networks. Another point is a high-level view of underlying infrastructure through a graph-based approach where the metrics per domain are mapped to the graphs, and we have all the metrics together in an end-to-end view. We developed a methodology to generate a service management model for zero-touch network. In short, the user or operator interacts with a chatbot in which useful features are extracted. We implement the chatbot interface using the platform HASA, which uses machine learning to identify key aspects in the user intent, include the type of service and the metrics. These features, along with a standard information model obtained from main SDOs such as 3GPP and etc., are used as input to generate the service management model. This model will be used to create policy and monitor templates. In our framework, we adopt Apex Policy Engine as core part of the policy component. Basically, Apex policy is composed of 3 main parts: state, event, and task. One or more states form an Apex policy. A novel method allows the automated Apex policy generator. Use the service management model as input. The generate process includes create an initiate event that triggers the execution of policy, a policy model formed of state and task, and configuration of the policy engine. So, at the end, we have 3 files in JSON format, specific for the end-to-end context. Now, for decomposing service management model into domain-specific policy, it's necessary to add two new steps. Select domain metrics and decompose end-to-end metrics into typically domain-specific values and conditions. So, for each domain, we have Apex policy files. For instance, if the maximum end-to-end latency of service is 50 milliseconds, so the method should divide the threshold value for each domain, for example, 30 milliseconds to transport and 20 milliseconds to run, based on every value is monitored for each domain. The policy component is illustrated in this figure, depicting the main parts, interfaces, and interactions with other loop components like analytics and knowledge. The policy is triggered from an input event, for example, message from monitor or pulling into the knowledge base. The event in JSON format is validated and sent to the policy engineer. Here is where the magic happens. The policy engineer performs the policy logic, and if there is a violation, SLA violation, or performs degradation, an output event is sent to recommended system to define the actions to fix the issues. A big challenge in automated policy generator is defining adequate actions when incidents occur. To address that, we propose a probabilistic recommended system that lists the actions ordered by priority from the knowledge base and select the actions with the highest priority. The system increase or decrease the priority according to result of the action execution, successful or unsuccessful. In these slides, I present some of our publications organized by area, for example, closed control loop and the orchestration, service management model, policy for multi-domain scenarios. We can highlight this patent, method for create an intent-based end-to-end network service monitor model, and this paper that address the diverse contributions of our research and artificial intelligence aspects in partnership with other students. Finally, the dream theme of this work is the potential of policy-driven CCL automation for service management. For that, we propose CLARA, that deals with CCL automation aspects, include intent refinement, implementation of CCL instance, and policy enforcement, and generate for multi-domain zero-touch networks. I'd like to thank you for your attention.